Alright, this is lesson 82, solving quadratic word problems. Students will solve quadratic word problems. That's our goal today. Whenever we have real-life applications of that in the shape of a quadratic graph, then we can apply the quadratic concepts that we've been learning, okay? Which is like vertex, solutions, and such. Here are the steps for today. Whenever you read a problem, or whenever you have a word problem, you want to read the problem all the way through and identify the question, okay? Identify any variables. There's always two variables, okay? And replace any values into the variables and solve what it's asking for. Okay, so the first one, let's go to number 1. Go to textbook page 29. Go to page 429. Because I'm just going to use the word problems that they have there. Example number 5. Okay, suppose you see an eagle flying over a canyon. The eagle is 30 feet above the level of the canyon's edge when it drops a stick from its claws. The force of gravity causes the stick to fall to the earth. The function height, or h, is equal to negative 16t squared plus 30 gives the height of the stick in h after t seconds. So graph this equation, or this quadratic function. So they give us a table because you want to graph it, right? Can time ever be negative? Is there such thing as negative time? No. Sometimes in some advanced examples you might say you want a negative time as an example, but no. So time could either be 0, 1, or 2 seconds, or we could do decimals too. And then the person on this example, they solved, if you look in the green box, there's how high is the stick at 0 seconds. How high is the stick at 0 seconds, everyone? 30 what? 30 feet, good. After 1 second, how high is the stick above the earth, or above the canyon? 14 feet. And then after 2 seconds, where is the stick? Negative 34. How is it negative? What's happening in this problem? There's a what? Well, how's the stick falling negative 34 feet below the ground? Canyon. It's a canyon, right? It went over the cliff, right? So you could imagine that there's a bird, right? Maybe there's a canyon like so, right? And there's a bird. That's not a very good bird, okay. But there's a bird, and it's dropping a stick, right? Does that make sense? Can you all imagine that? Okay, so you have to think about the problem. You're not going to draw a picture. Sometimes if you need to draw a picture, you can, but you don't need to do that. I'll erase that. Okay, so first thing you want to do is read what's going on. We know that we want to know a few questions here. We're going to graph it. So you would graph it like you normally would, and you're going to figure out what the height is. Okay, so how high is the stick after... Or how far did the stick fall after one second? I'm sorry? 16 feet, right? So let's practice graphing it. So what I'd like you to do in your notes is let's make a table, okay? So T, and just like they have, H is equal to, actually just put T on the side, or H on the side, I'm sorry. So T is kind of like your x-axis, right? There could be 0 seconds, 1 second, 2 seconds, 3 seconds, right? H is the height of the stick after that time, okay? So we know at 0 seconds, if I were to plug in 0 as my T, we just go H is equal to negative 16 T squared, and instead of T we're putting in 0 squared, plus 30. Okay, which is equal to or 0 squared is 0 times negative 16 is 0, and 0 plus 30 is 30, right? So we know that at 0 seconds it's 30 feet high, okay? That's just what our table says, okay? How about 1 second, okay? We plug it in again. H is equal to negative 16 t squared. Instead of t, we're going to put 1 this time. That's the time. Plus 30. Okay, 1 squared is 1 times negative 16 is negative 16 plus 30. Negative 16 plus 30 is 14. Right? So that after 1 second, this stick is 14 feet above the ground. And we keep doing this, okay? Next one, let's put in 2. H is equal to negative 16 times 2 squared plus 30. 2 squared is 4. 4 times negative 16 is negative 64. Negative 64 plus 30 is equal to negative 34. So that's how far the stick is fallen beneath the canyon's edge, okay? So continuing on, what about 3 seconds? How far is the stick from there? Let's have you guys do that one. So I want you to plug in. Instead of t this time, I want you to put h as equal to 3. I'm sorry, not h. T is equal to 3. So negative 16 times 3 squared plus 30. Okay? By yourselves, ready to go? 1 second, 2 seconds, 3 seconds. And let's just say that the graph was going by. Instead of 1s here, let's assume that these are all by 10. So instead, this is like 10, 20, 30, 40. Right? At 0 seconds, the graph is at 0.30. At 1 second, we're saying that the stick is 14 feet high, so we'd say it's here. At 2 seconds, it's at negative 34 feet, which is about here. And at 3 seconds, it's at 114 feet, or negative 114 feet, which is all the way down here. 2, 3. Right? Is that right? No, it's a little. So I could imagine that the bird drops the object beneath the canyon. Now, the canyon's height is actually right here. Right? And I don't know at what point it starts falling, but that's where the canyon is, right there. Okay, so this helps us understand what the problem is, what's happening in the problem. Does that make sense? Yeah? Okay, so let's go do number 2. Let's right beneath it at 5A. So, yes.
Can you explain what happened when you got negative 14?
Negative 114 or negative 14?
Oh.
Okay, 3 squared is 9.
Yeah.
Okay, 9 times 16 is 144, or negative 144. Okay? Negative 144 plus 30 is negative 114.
Oh, okay.
Does that make sense?
Yeah.
Okay. Now here's a question. Let me ask you a different question. How far has the stick fallen in 3 seconds? Think about that. How far has the stick fallen from the bird in 3 seconds? Discuss with your neighbor really quick. Ready? So example 2 is just right underneath it. Let's suppose you have a squirrel that's in a tree that's 24 feet above the ground. She drops an acorn. The function h is equal to negative 16t squared plus 24 gives the height of the acorn after t seconds. Graph the function, okay? So just like before, we're going to start with a chart, but instead of x and y, we're going to use t and h again, okay? Is there such thing as negative time? No. So let's go, how many seconds do we need to be talking about here? How many seconds do you want to talk about? 2, 3 seconds? Right? Okay. So, let's look at this. 0. How high or how far did the acorn fall after 0 seconds? Let's say no time has passed. The squirrel let go of the acorn. It's disconnected, but it hasn't fallen yet. How high is the acorn from the ground?
24.
24, that's right. So we could just assume that. Now you could plug that into the equation, but you could just assume that. So h is equal to negative 16 t squared plus 24. Right? Let's do the next one. Let's put 1 in. Negative 16 times 1 squared plus 24. Okay, 1 squared is 1. 1 times negative 16 is negative 16 plus 24. What's negative 16 plus 24? What? 8. Good. So that's after 1 second. The acorn is 8 feet above the ground. What about 2 seconds? What's the answer for 2 seconds? Go. So by yourself, you're going to be telling me AH is equal to negative 16. T squared says be 2 squared plus 24. When you have an answer, please raise your hand. If the answer is negative 40, then I got a question for you. In this example, is there such thing as negative 40? No, why not? There's no canyon, right? Do acorns just go through the ground? Are they like ghost acorns? Do they go through the ground and just keep falling to the middle of the earth? No. So is this a viable answer here? Negative 40? No. So what we're going to do is use that instead to graph. Okay. So I'm going to make my graph still as 0, 1, 2, and 3, and then we'll do this again. Why don't we use let's see, 10, 20, and 30, right? Make a smaller graph. Okay, so 0, 24, we're going to put our point down. Then we have 1 second. It's at 8 feet. And then at 2 seconds, it's at negative 40 feet. Which is way down here, right? So is it possible that the acorn goes underneath the ground right here? No. So let's just erase that last portion with our pencils, or not even mark that. And that's it. That's the shape of the graph. Okay? So as time falls, or as time passes, the acorn falls, but it hits the floor. Okay? Now, how do we figure out how much time passes for the acorn to hit the ground? What's this point called on the graph when we talk about quadratic equations? A zero. It's called a zero. What else is it called? She's right. I did teach you that. What other words are names for zeros? Root, right? Or, what's the last word? Solution. How do we find the solution here? Okay, are there any points hitting it perfectly? No. So what's the more accurate way to find this? What's y equal to here? Y is equal to 0, right? That's why it's called the 0. So we would set, instead, this is not called y anymore, this is called t, so we'd set t equal, or not t, h equal to 0, okay? So we're going to take this, instead of h, we're going to put 0, and write the original equation. 0 is equal to negative 16t squared plus 24. Okay, in this example, I got a question for you. What's a equal to? What's a equal to? No. What's a equal to? What's the number in front of t squared? Good, negative 16. What's b equal to? There's no b. What's c equal to? Good. Is there a b? No. So what are the methods I should try to get first? Is there a GCF?
Yes.
What number goes into all the 16 and 24?
4.
4, good. So let's take out 4. 4 times negative 4 t squared plus 6. Okay, is equal to 0. All right. And actually, I'll do that. Yeah, that's good. And watch this trick. I'm going to get rid of this 4. Check out what happens. What happens when I divide both sides by 4? What's 0 divided by 4? 0. Good. What's 4 divided by 4? 1. So they cancel out, right? So we got 0 is equal to negative 4t squared plus 6. What else could I have taken out? What other GCF? 2, right? So we got 2 times negative 4t squared plus, or times negative 2t squared plus 3, right? And we're going to do that again. Set it equal to 0, divide both sides by 2. And we got 0 is equal to, I'm going to bring it up here, negative 2t squared plus 3. Okay, what's a equal to now? Good, negative 2. What's b equal to? Okay, good. So what's the clue when we don't have a b? We could either do 2 things, difference of squares or take a square root. Which one can we do? Guys, wake up. Nope. Take a square. Right. So what we can't do difference of squares, so we have to take a square root. So we're going to add 2 squared to both sides, so it's going to be 2t squared is equal to 3. Divide both sides by 2. So I'm going quickly here, which is equal to 3 over 2. We can't really simplify that. What's 3 divided by 2? It's like saying 1.5, right? Take a square root of both sides. So t is equal to positive and negative square root of 1.5. Now I got a question for you. Can we ever have a negative time? No. So should I put a negative sign there? No, let's take out the negative sign. So that's your answer, square root of 1.5. You could go on your calculator and just put that in there to find the exact answer. Then you just go clear your calculator. 1.5, take the square root button, and you get 1.224. Okay, seconds, right? That's the time that passed. And that's how you do number 2. Okay? Does that make sense? Okay? So, how many seconds pass by until the squirrel's acorn falls to the ground? 1.224, right? That's where that point is. That was our solution. Okay? Right there. Alright. Well, that concludes this lesson. I'm going to end it there because I want you to have some time to practice that. We have about almost 10 minutes left.